Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes the arithmetic mean and how to calculate it. Let's get started. One important way to characterize a data set is with a measure of center. We want something that can tell us where the data are amassed or centered on a number line. This is a measure of center. Now, the arithmetic mean is perhaps the most widely used measure of center. Many statisticians abbreviate this and just call it the mean. Most people call this the average. It's the same thing. As Shakespeare once said, a rose by any other name would still smell as sweet. I don't know why statisticians feel compelled to call the average the mean. Maybe it pumps up their ego to think that they're talking about something most people understand, but don't know they understand because they're using a different name. I don't know. I just know you don't need to get confused because the average and the mean are the same thing. Now, equations using and describing the mean use special notation. These are mathematical symbols you may or may not be familiar with, so let's go through them and make sure everyone's on the same page. The capital Greek letter sigma will denote the sum of a set of values. So when you see sigma, you're going to know that we're talking about a summation, which means we're adding things together. X is the variable usually used to represent individual data values. The lowercase letter n represents the number of data values in a sample, what we call the sample size. And since lowercase letter n represents the size of the sample, a capital letter N will represent the size of the population, or the number of data values in a population. You'll see this convention quite frequently. The author of your textbook often uses a lowercase letter to represent some value for a sample, and then the corresponding uppercase letter to represent the same value for a population. There are exceptions, and we'll describe them as we cross those bridges, but this is generally the practice you'll see. Now, mathematically, we can write an equation that serves as the definition of the arithmetic mean, and we can do this for both samples and populations. The sample arithmetic mean is denoted with a character called x bar, so called because there's a bar placed over the letter x. X bar, as you see here, is equal to the sum of our individual x values divided by the sample size n. So we're adding up all the individual values in our data set and then dividing by the total number of data values in our sample. The population arithmetic mean is denoted with a lowercase Greek letter mu. Mu is defined as the sum of x over the size of our population, represented by a capital letter N. Remember, big N is for the population, little n is for the sample. But you can see that the way you're calculating the mean is pretty much the same. You take the individual members, add them up, and then divide by the total number of members. All you have to do to know the difference is recognize x bar and little n go with the sample, and mu and big N go with the population. Now, using the mean as a measure of center carries with it advantages and disadvantages. The advantages to using the arithmetic mean explain some of the reasons why it's most widely used. First, sample means drawn from the same population tend to have less variation than other measures of center. No matter what sample we take from the same population, the mean value that we get for each of those samples is going to be roughly the same so long as we sample randomly. The mean also takes every data value into account, so there's no taking some of the data and then estimating the rest. The mean takes into account every single data value. Now, there are some disadvantages to using the mean as a measure of center. First off, the mean is extremely sensitive to every data value. Because we're using every data value, if one of those values is extreme, such as an outlier, for example, it can have a dramatic effect on the value of the mean. And because of this sensitivity, the mean is not what we call a resistant measure of center. The value of the mean cannot resist the influence of an extreme value in the data set. So if you have some significant outliers in the data set, the sensitivity of the mean to every value in the data set will manifest itself with a potentially radically different mean value for your data. Let's consider an example of, chocolate. Let's consider an example of how to calculate the mean. Suppose we were to count the number of chocolate chips and chocolate chip cookies, and we got 5 chocolate chip cookies. What, only 5? I see at least 9 there in the picture. So we count the number of chocolate chips in each cookie and obtain the following counts. The first cookie we have 22 chips, in the second cookie we have 22 chips, in the third cookie we have 26 chips, in the fourth cookie we have 24 chips, and the fifth cookie 23 chips. And it took an awful lot of self-control to count the chips and not eat them. Now, we are asked, what is the mean number of chocolate chips per cookie? Well, if you're the Cookie Monster, Cookie Monster, you're probably not going to have much interest in this question. All you're going to hear is the word cookie, and then maybe break out into the song, C is for cookie, that's good enough for me. But since most of us aren't Cookie Monster, we're actually going to have at least a little bit more interest in answering the question. So, to calculate the mean, we simply take each of the individual data values in our sample and divide that sum by the total number of data values in our sample. So here in the top part of our fraction, we're adding in the different values for our sample. That equals 117. There's 5 values in the data set, so we have 5 on the bottom of our fraction. We're dividing by 5. 117 divided by 5 gives us 23.4. This means we have a mean value of 23.4 chips in each chocolate chip cookie. Now, you can join Cookie Monster if you want and have a cookie. And I think I will. That brings us to the end of this mini lecture. Thank goodness, I need a chocolate chip cookie. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.